Okay, so a while back, I did a series of videos that talked about adding additional SATA ports to your, in this case, a G3. And what I ended up doing was, I was able to add 4 SATA ports. Just use this for booting up into Proxmox and TrueNAS. And I connected up 4 of the 2.5-inch drives, have it kind of sitting in this sort of, I don't know, cage. And it was powered, or is powered, by this connector here, which is 2 USB connectors, just goes in the back here. And this will power all 4 of them. I've had it running now 24/7 for quite a while. It works great. But I wondered, what will it, or what would it take to, instead of adding 2.5-inch drives, what if I added the 3.5-inch drives? And one of the reasons I asked or was wondering about it was that when I got rid of our big tower and went with in my case, a G5 mini PC, is I still had these drives around. And I happened to look through my inventory of them, and I have 4 1 terabyte 3.5-inch drives, which kind of mimics this, which is 4 of the 2.5. And I thought, well, what is it going to take to be able to get them connected? Now they use the same SATA interface, so I knew I could get connected that way. But the trick is power. And that's the tough one, because with a 3.5-inch drive, you have to have both 5 volt and 12 volt. These only need 5 volt. And we can achieve 5 volt just by using the normal USB ports. But the USB ports are not going to create enough 12, or even if it could create 12 volt, it's not going to create enough to run the 3.5-inch drives. And in my case, I want 4 of them. So it's going to be even more of an impact. And so I started looking around for some options. The first thing I looked at was this little gizmo that I've had for a long time, and it allows you to do data transfers of using different kinds of media. You can put the old school, I believe the old school IDE drives on here. It's got SATA. I think it's maybe even 2 kinds of, or maybe this is the 2.5-inch IDE, 3.5. And then there's like an on-off. But one of the things that it has here is a Molex connector. And what that connects to is this cable here, which in turn, of course, is part of a power supply. This is a 12 volt, 2 amp power supply. So it puts out around 20 watts of juice. And you plug it in to here, and then you can run your 3.5-inch drive, SATA drive off of here, because it's going to supply both the 5 and the 12 volt rails on here. So what I first started is I took this, and I had an adapter that went from Molex to the SATA power. So I could connect on here, it does a conversion, and then it can slip right in here, and then you can power your drive. So if you do that, you could power these if you wanted to. And I was able to power at least 1 drive, and to some extent I could power more than 1, but really this is only putting out a small amount of juice. And I was also worried about overloading this power supply and shorting it out, etc. So I started looking around for other options. Different sources came up with different ideas as far as how much juice I would need. But one of them stated that if I wanted to do about 3 to 4 drives, I was going to need a 12 volt, 10 amp power supply. So that puts out about 120 watts. And so I looked around to see what I could find for that. I ended up finding this on Amazon. One of the reasons I liked it, it does claim to be UL listed. Got some, pretty high marks and such. It's only got a just a normal plug here. I guess you probably could modify and stick on a three prong, but I'll experiment with that some other time. But the other end is this barrel jack. They sometimes call this a 55-25 as far as the sizing and what the size on the inside. And you'll see a lot of these. I saw ones that would be, let's say, 12 volt, but maybe 5 amp or 2 amp or etc. You might be able to get by with the 5 amp one, but I thought, well, if the recommendation was 10 amps, if you're going to put 4, I want to do that. Plus I'm wanting to run a fan as part of this whole setup too. So I thought, okay, I'll go for this one. Now what's interesting enough, now this is going to connect in to pretty much the same sort of one of the, these sort of multi-headed SATA power distributions here. Let me show you that one. So here's the converter that's going to take that 12 volt connector and turn it into something that can be used for SATA. Now, you do want to make sure that, you may see some of these around. Make sure it's doing all 4 of the wires, because some of them only do 2, and a lot of times it's all it is just 5 volt. So this is going to plug in to here. And then this is going to plug into here. And obviously this is the 2.5, and I'll show you a little bit the 3.5 setup. But I decided to use the same sort of, I bought a second one of these because this way I could run 4 drives, and I've still got 2 more if I wanted to add a 5th. And I also use one of them to run the fan. They do sell this adapter, and it will go to 4, it branches out and turns into 4 of them. And that would be great because there's one less thing you're, having to monkey with as far as connectors. But then I'd have to figure out how to do the fan, and I'd have to do like an offshoot of one of them, and all that kind of stuff. So I figured, well, I know this works really well, and I like how it's set up, and then it makes it easier. Just works. I like things that, even though I'm dealing with 2 basic different things, certain things I like to keep the same. So that's why I was keeping this sort of multi-headed Hydra connector there. So this goes into here. This connects on there. And then I've got another adapter that comes off of here that allows me to run my fan. It's got, it connects in on the SATA, and the other end is a 4-pin that you take the fan and connect it into there. And I just happen to also have a extra fan laying around, so I integrated into it. So let's move some of this, and I'll show you the enclosure that I'm using for the 4 drives. Before I get too far into it, I just want to show you how much larger everything gets when you go from the 2.5 to the 3.5. So here's the full enclosure. I'll even put it on its side here just so we can see a relative size. And here's the little 2.5. I mean, this is easily probably 6 times the size of this one in order to be able to accommodate the 4 drives. So when I was looking around for something to put the drives in, there's a lot of choices. I could very easily have just purchased a sort of a ready-made enclosure that's got power supply, fan. You just, stick the drives in and maybe your SATA connector, and you'd be done with it. Those were a little pricey for me. They were in probably more of the 150 range. So I picked up this one. It runs anywhere from $20 to $25. There's a space for a fan. I happen to have a fan. They do sell, I think one of the sellers included the fan if you really needed it. What's nice is it doesn't have a top or a bottom. You can flip this either way, which sometimes makes it handy if you want to put your drives in, but maybe you want the SATA connector to come from a different direction, or the power, etc. They all click in pretty nicely. It comes with these little rails. A little tip, make sure when you put them on that, when I first put them on, I had them too low down here and it didn't work. And also make sure that the the holder clip is where the connector is. When I first did it, I had them coming on the other side and they wouldn't slide all the way. So make sure this way. And something strange, this says left, although it's on the right hand side, but it's upside down. So I don't know if I turn it the other way, I don't know, but however it is, when you're putting them in, try to make it so that it looks like this, and they'll go in and everything will fit nicely, so that way you still have a little bit of a gap at the top. So we can slide in, and it makes a fairly, oh, I'm getting caught on here, a fairly nice click. There you go. And this is what it looks like from here. And you will notice that the SATA power is up toward the top. That may be, again, one of the reasons why if you put everything in and you like it, you may want to turn it upside down, and then that way the SATA connector is kind of more toward the, when you go to connect, it's on the bottom versus at the top. I decided just to keep it on the top. It didn't matter too much to me. That way I could also run the connector. This is that adapter I was talking about before. It goes right into the SATA, has the 4-pin, goes right in there. It's pretty heavy, it's it's solid, especially you get 4 drives going in there. And you want to take this off, and then you screw the fan into this enclosure. Make sure that your air is going outward. And so one way to make sure that you're doing it the right way is when you screw it onto here, if it's sitting like this, you should see kind of like the logo for the fan up here. And then on the flip side is where you would see like the, I don't know what you call it, like the grill work would be on the outside. So the grill work is right underneath here. That way you know that the air is going that way. It's supposed to draw the air away from the heat. And then over here, of course, we've got the other end of the SATA power. We're going to plug that into that adapter. Let me get it connected up and kind of show you what it sounds like. And then we'll go into TrueNAS and I'll show you how it's set up. I did a little test of them sitting idle, and it was drawing about 30 watts. When I first plugged it in and started everything up, it did shoot up to like, I don't know, maybe 55 watts, something like that. So it's still not using anywhere near the 120. So you're pretty safe on that. Again, you probably could get by with one of those that's maybe only 5 amp, 12 volt. But really, it's not like there's a huge difference as far as cost between the two. They're all pretty much like this. I tried to find some that were 5 amp and had the Molex on the end, primarily for running fans. So it didn't really have the 12 volt rail. So it didn't have all the wires. And you could tell because as you look at it, there's only like 2 sets. There's only a ground and the 5 volt. Okay, I'll speak a little louder so you can hear me over the din of the drives and fan. But I've powered it up. Got my network connection, power on my G3. This should boot into Proxmox and then allow me to start up TrueNAS. I'm using the same TrueNAS that I had when I had the 2.5 inch, because that's why you may notice there's little numbers on here. When I disconnect it, I want to make sure that I put all the drives back in the same order, so that way if I go back to the 2.5, I can restart TrueNAS. It will see everything and start out. Right now in TrueNAS, it sees the storage array of the 2.5 as basically being offline. So we have this one, which we can now go in and create our own new storage array using the 4 in here. So let's switch over to that. Okay, so we've got the Proxmox cluster started up right now. This happens to be on this PVE4. Here's our TrueNAS. I'm going to go ahead and start it up. We can go into console and watch as it's doing its thing. Well, this is embarrassing. Before, when I was moving everything around, I disconnected the power from one of the drives. So when I went in here, it's not showing. So I'm going to shut things down, add that drive back in, and then we'll continue. Well, there we go. So much better when we've got all the drives working. It was very interesting, though, when I'd first gone in, because I had previously created a data set, or I should say a pool here, and it was saying degraded. And I'm like, whoa, wait a minute, why was it degraded? Well, it's because obviously one of the drives wasn't there. And you'll notice that this one says offline. This was the one that we created with the 2.5. And so later, if I reconnect those, then I can, see them again. Okay, I believe what we want to do, so that I can show you kind of, how we go through as far as creating that data set, is I believe we could do an export disconnect. And then we're going to say, we're going to delete, we're going to confirm, type this, export. And this is kind of, it's probably good to know, because sometimes you may be, experimenting and just want to try different setups. Okay, so now we come in, and this would be like what you would see when you first go in to set up. Hey, I've got 4 unassigned disks. What do I want to do with it? Okay, well, let's add it to a pool. And we want to do a new pool. Say add disks. I'm going to recreate it as SATA 3.5. The layout, I'm going to do it with the RAID Z1. And disk size is, I guess that's only seeing. Width just says how many drives you're going to use for it. So I'm going to say 4, because sometimes people do 3 and maybe they'll have a spare, various ones. It's just going to create 1 VDEV. And pretty much at this point, you can do all these. They're all optional. I'm just going to say save and go to review. And then we'll say create pool. What I can do now is that I've got my main data set, the SATA 3.5, but what I can do is I can create some shares from it. I'm going to use this to do some speed tests, and also to see in terms of how it affects the overall power usage. So before I do that, I'm going to shut this down so I can plug in the kilowatt. So here I'm copying over some of my old videos, around 32 gig of them. And what is that, about 112 megabytes per second? Not too bad. It's going to take about 5 minutes. I'm going to try that, see how that goes, if it actually takes that speed or that amount of time. And then I'm also going to try it and see what it does as far as the load in terms of power. One thing that I find interesting is this disk health. And it's telling us that the highest temperature so far it's gotten is about 28 Celsius, lowest about 20, average about 25. I mean, it hasn't been running that long. I'm touching the enclosure, and it's still cool to the touch, and even the topmost drive is cool to the touch. So that's kind of nice. That had pretty consistent speed. You know, sometimes you do these things where you're copying stuff and it starts out really fast and then goes real, slows itself down. But that was pretty consistent all the way through, and it took about the 5-6 minutes. So okay, I'm going to shut down now, and we'll check the power, see how it fluctuates when we do some more intense copying back and forth on these drives. So I'm booted back in, and kilowatt is showing about 30 watts sitting here. And it did get down to about 8 at one point, but that was before the actual VM started up and such. So let's try doing some copying and see if how it affects power draw. So I'm going to try copying from the drives onto my desktop. That's usually, the pull is actually pretty good, because then it can kind of pull from just about, any of the drives. So we'll see how that goes also as far as speed. Well, it's a lot slower than I assumed it would be. No change on the power. If anything, we're down more in the 26 watt range right now. We'll let this run a little bit, and I'll see if we have any change in power. And then I'll try also maybe copying some more files over. Decided to go back to copying stuff to it to see how it affected. Yeah, the read speeds weren't as good as the write speeds. So here we're writing, and this is pretty consistent. The power draw, it seems to vacillate. It goes between about 26 and 33, goes back and forth. Most likely, I would assume, is it's perhaps writing to more drives, maybe. But there's no big change, big surge. When I first plugged in the power supply, it did surge up to about 50 watts. That was about the highest it went. Okay, I'll just let that go. Well, hopefully this kind of gave you some food for thought. And, especially if you're wondering, hey, how can I hook up some 3.5-inch drives? I got a whole bunch of them left over from various computers that I've gotten rid of, and I'd like to, utilize them.